So my name is Bart. I am from the Platform and Observability team at Digital Development, and I'm doing this talk with my coworker and teammate Sven. Sven, say hi.
Hi, everybody.
And we're from digital development. So to give you a little bit of context on that, digital development is the department that does all of the digital touch points of the customer, right? So you can think of the website primarily, but also the app, Google Voice Assistant, and what many people don't know is we are also responsible for the home delivery proposition. So all those vans driving around the country delivering groceries to people, all the IT behind that, that's us as well. And today we kind of want to take you on a journey through some failures that we have encountered and obstacles that we have had to overcome. And we want to discuss with you the exact obstacles that we met and what we did in order to overcome them, and then the future that we want to go to, in particular about our monitoring setup. So let's get started. I'll take you in the beginning for the journey, and then Sam will take over halftime. So going back to the genesis of our story, in about 2016, there was a Vanguard team. And this team really decided that the way that things were working was no longer working. They wanted to go in a new direction, screw the way that we're doing things right now. So they went ahead and they said, we're going to do something like a service-oriented architecture because that's the future. We're going to use open source software primarily, no more paying for everything through the nose. What we're going to do is we're going to use containerization. We're going to do everything orchestrated on Kubernetes, and then we're going to build this big open API platform of which everyone can make use of. I mean, these were grand visions that these people had. So, and they succeeded for the most part. They got themselves a couple of VMs that were containerization compatible, so represented here with these kittens. And what they did is they bound them together through Kubernetes, and then they built a bunch of apps on top of that. And they basically rolled out a platform in a couple of months. It was truly amazing. But there was one little snag because these were all developers, and really before this, their only responsibilities were for applications, but now they were responsible for a lot more. They were responsible for the entire orchestration layer that they set up, but they were also responsible for all of the nodes that made up this new cluster. So the question is, well, what happens when things start catching on fire? And you need to know that things are catching on fire, and you need to know kind of why they're catching on fire. So this team was now also responsible for monitoring this entire system. So obviously what you do is you start to Google, as this team does, how do you do this? Because every single technology was new. And the primary candidate that came out is Prometheus. And Prometheus, for those of you who don't know, is a cloud native computing foundation application. It's one of their first entries. And Prometheus allows you to monitor and alert based on particular metrics given from your monitoring. And it cannot do this. Basically, everything can kind of be monitored through Prometheus. And if you want to know more about Prometheus, there was a great talk yesterday, so you can look that one up as well. It's really awesome. But anyway, on with our stuff. So what these guys did is they got Prometheus and they got it installed on their system, and it's actually quite simple because they just put it in a container, you plop it on Kubernetes, and then to get started, you just Google up, well, give me some configurations for Prometheus on Kubernetes. You tweak it a little bit, you put it in your cluster, and it's there. And the magical thing is that, you get complete end-to-end monitoring from your machines all the way to your apps pretty much within a day. It was truly a magical time. But the magic soon kind of wears off because this platform was extremely successful. And when you start becoming successful, obviously you need to start to scale. And scaling is kind of like taking a magnifying glass onto every single imperfection that you have, and every single small mistake turns into a huge mistake, and your foundation can become quicksand rather quickly. So what happens is, well, we had one team, and it was this Vanguard team that was on this platform. So every single alert, all the monitoring, it went to them. But then you start to onboard more teams, right? There's an additional team, they have their own apps. So that little rule file that they had and the little configuration, well, they have to hack it a little bit. And they have to tweak it to make sure that this new team fits and that the alerts go out to the right people. But everything was still okay. But then you get another team and they also need to be onboarded, so you apply the same fixes. But this team has some special requirements because they want to get called for service A and they want to get called for service B, but they don't really want to get called for service C, so they need some sort of exception. So you kind of hack that in. And then you have another team that does want to get called for service C, but only during office hours or only in the evening. And so, and they only want to get called whenever one of their dependencies isn't down. And, you know, the more teams you onboard, the more of these exceptions you're getting. And you know that you really screwed up the moment that you open your rule file and the little scroll bar indicator on your editor becomes so small that even my high pixel display has to start doing sub-pixel rendering. So yeah, it became a mess, right? Because there's no validation on the configurations, there's no testing, we are lacking complete deployment automation, we're rolling everything out through Helm manually. There's no concrete strategy of expansion. Every problem that we met, we just sort of created a tactic to solve it at that point. Occasionally some restructuring and improvements, but nothing major. And the big bottleneck was we had one giant config that was completely separated from any applications or systems that it was monitoring. And that's the first problem. Then we got into a second problem because, well, we have all these new teams and they're building all these new services on our stuff, and that's a lot of data. Now, Prometheus is an amazing application and you can just scale it up. So we did. There's more data, Prometheus scales up. And then we had all of these teams with these specific requirements. So we needed additional metadata in all of our metrics in order to, well, in order to handle that. So Prometheus becomes even larger, right? And then stuff really hits the fan, because at this point, the developers start to recognize the power of Prometheus and they start to recognize all the cool graphing that they can do with it. So they start making dashboards. And if the data exists, someone will find a way to abuse it. And in this case, you might have someone who says, I want to create a dashboard and I want all my data for the past 2 weeks. I want every single percentile of every single service that I have, and I want it for every single one of my dependencies that I have as well. And I all want it in one dashboard, and I all want it refreshed every minute. So that's when stuff gets really, really big. And we were basically kicking down Prometheus's door every day and punching it in the face until it gave us the data that we wanted. And then it dies. And it did. Multiple times a week, Prometheus would crash, or we would lose data, or sometimes even it would take down the entire node it was on and any other unsuspecting applications that were next to it. So it was really, really a sad time. And we sort of saw something that was going to happen in the future, because, well, we're going to the cloud, and the cloud has a lot of clusters that we're going to run there. So in order to run this situation on, I don't even know how many clusters. I mean, I'm getting tired just thinking about it. So we needed to change our ways, and it was really our ways that we needed to change, because we were just being very abusive to Prometheus and to our monitoring setup. We were leaning on it too heavy, we were too complacent in it. So we really had to sort of take a broom, sweep it all, and make sure that we get a system that was robust and that was ready for the cloud. So Sven is going to take over, and he's going to tell you a little bit about all of the actions that we took in order to get us out of this situation that we got ourselves into.
Well, thank you, Bart, for getting us into hell. Sheet.
Yep.
Okay. So first, if we want to go to heaven, we first have to get out of hell. So I asked my boy Dante to draw us a map. And I pinpointed where we are, and you can see, yeah, we're right there at rock bottom. So just a quick summary of problems we needed to solve. Firstly, we have like this unmanageable configuration of the rules file, alert files. We have to get rid of that to have scalability. We need to get rid of the excessive load of Prometheus. At the moment, like Bart explained, it crashes a lot, takes down nodes every couple of days. We need to have a scalable solution with the vision on Azure, and we need to make sure that things are testable. So the first thing we did was split up the rules and alerts file, and we used the Prometheus operator for this. And I heard that you are also using this. So what it essentially does, it does a couple of things for us. It manages our Prometheus and alert instances. It looks what applications to scrape, and it searches which data recording and alerting rules that exist on the cluster. So what it does, you have like all these different custom resource files, like a Prometheus rules, in which all of the recording rules and alerting rules are defined, service monitor, how Prometheus monitor, how Prometheus let monitor a service, and a node exporter, like how to get metrics from the nodes itself. And what it does, it searches for all these configs and merges it to the Prometheus config and adds it to Prometheus itself. Well, it's nice because what you have is like you have all these kind of specific configurations which the developers can deploy themselves. So you can get really specific for the rules. So if you have like a rules file and alerts file, you can add them to the code themselves, and through a Helm deployment, you add it to the cluster. And the Prometheus operator will pick this up and add it to the configuration. So this would also mean that every one of those configs is individually testable and deployable. And like this whole setup is really easy to transfer to Azure. So this takes care of the unmanageable configuration part. So we're a little bit higher in the rings of hell. So the second thing we have to tackle is the excessive load on the Prometheus services. So what we did, instead of having like one giant Prometheus that takes care of everything, we split it up in two. We had on one side, we had the cluster Prometheus, which takes care of all the node metrics, the ingress, the Kubernetes services. And the other side, we have like the application Prometheus, and that would take care of all the metrics from the application themselves. Beside that, it's also possible to make a domain-specific Prometheus service. So if you have like a load balancer that's creating a lot of metrics, and it can't be handled by either of the other two, you can make a specific Prometheus server for that one. But this would mean that there will be a lot of Prometheus servers in your clusters. So what we did, we used Prometheus to be like a proxy between, in this case, Grafana and Prometheus services. Because if you a developer just needs to say, okay, I want metrics from this cluster, and he must not have to think about like, okay, I want this specific metric, and it has to come out of like the cluster Prometheus. It's too much work. So Prometheus just bundles it all and makes it like as accessible as one data source in Grafana. So at the moment, we're not in heaven yet. We have like a quite stable situation where our servers aren't crashing anymore. We have like a dynamic environment which developers can push their alerts and recording rules themselves, but still, it's not good enough for us. Like the ascension to heaven. This will add a couple of new challenges. There will be like a lot of clusters, and this will mean a lot of data sources in Grafana, like a lot of clusters that get added like at randomly. Then there will be a new cluster here, then that one will be deleted. So it's a lot of manual work to track all of these, and there will be errors made in there. And with our focus on the service level objectives, we need to at least have 2 years of storage and from a single data store in the cloud. So to fix this problem, we made a Prometheus discovery operator. And what it essentially it's built on 2 parts. The first part is the discovery job, which talks to Rijnders about, hey, what kind of clusters are they running? And then it would talk to each individual cluster, which Prometheus service do you have running? So it collects all of these and makes CUDs from them. And then the second part of the Prometheus discovery operator will check to Grafana, hey, we have like this Prometheus server on that cluster, do you already have that added? If not, it will add them. the second part of the long-term storage, we made a federated Prometheus. And the federated Prometheus will like scrape all of the other Prometheus services and will look at recording rules with the long-term label. So a developer can say, okay, I think this metric is important. I want to store it for a longer time. It just has to add the long-term label on it, and the federated Prometheus will take that metric and store it into Thanos. But also this will create the same problem we had with Grafana. A lot of new Prometheus servers get spin up all the time. So what we did after we added like a new Prometheus server to Grafana, it will also add it to the federated Prometheus configuration. So that's kind of what our Heaven at the moment looks like. We have like a fully dynamic setup. If a developer requests a cluster, it will be automatically created in Grafana too. So yeah, of course, we're never finished. We'll always have a vision on the future. So we'll take a couple of things here, what our focus will be on. So at the moment, we really have like an on-prem alert manager and an Azure alert manager. We want to combine these. We want to extend the overall Thanos integration across our entire stack. Our service level operator. So we have like recording rules and alerting rules that developers can deploy with their Helm charts. We want to do the same with service level objectives. So they can just put it in their Helm charts and it will be deployed and automatically picked up. This also is picked up by our dashboard automation. So like if a developer has like a new deployment, there will be automatically a new dashboard generated in Grafana with like the SLOs. Beside that, we have really a focus on observability at the moment. So that's like the metrics where we talked about this talk, the logs and the tracing, and then especially the metadata between those. So like you get an alert, there has to be a simple way to get to the logs, and from the logs there has to be a simple way to get to the tracing that's accompanied with it. So yeah, I think that's our next Heaven.
Yeah.
So thank you all.
Thanks everyone. If there are any questions, please feel free to ask. I'll stop sharing my screen and we can go through them. I think there's a Q&A thing.
Yeah. Well, yeah, we love the kittens too, so yeah.
All right. Yeah, so there are plenty of people in the room who commented on how much they loved you and the cats theme and the animations. For now, we have one question. So how is Azure working out for you, given that we are only in the Google Cloud?
Yeah, that's a great question. For us, digital development, Azure is amazing. And that has a whole bunch of reasons that I think would take way too long for this time that we have left. But primarily, it's working out great. What we've done with our team is there's been a complete push for a pipeline. There's actually a talk that we did, or well, two of my coworkers did about 4 months ago on the Kubernetes days, Kubernetes community days, where we discussed the deployment pipeline that we've created for Kubernetes. So we have a whole pipeline that's set up that allows you to basically upload a YAML to our Git repository, and it describes a cluster, and then we have a whole pipeline that rolls out that complete cross-cluster setup across dev, test, acceptance, and production. And all of that is made possible through Rancher that we're using and Azure. And that's working out really great for us. And the second thing that's really nice about Azure is the integration that we have right now with GitHub, because well, GitHub is taken over by Microsoft, and the fact that all of Albertine technology is on it. So to give you a little indication, we are digital development, which is part of the larger online technology. And primarily we have been very separated from them in order to be more agile. And the great thing about Azure is that it allows us to merge these two things while giving us still control over our own parts and our own little sections. So Azure's been working out really great for us in that respect. Alerts
Great.
and escalations, incident management.
Yeah.
Awesome. Okay, so let's see.
So you have another question about indeed alerts and acceleration. You can tell maybe about it.
Yeah, so we are using OpsGenie for our alerting management. So that's what's going to call us at night. And for incident management, we're using ServiceNow. Primarily, that's something that has always been used by AH technology. And what we've actually done is we've created a bidirectional link between those two, which means that any sort of alert that gets raised in OpsGenie automatically also gets a ticket created in ServiceNow, and any sort of actions that happen in ServiceNow then get reflected in OpsGenie, which means if I get a call, it will create an incident for me in ServiceNow and it will alert me through OpsGenie. If I then act it in OpsGenie, it will automatically assign it to me in ServiceNow, and then in ServiceNow I can do stuff like work notes and keep people up to date on my progress with the incident, and then if I close it in ServiceNow, it will then also get closed in OpsGenie. Or if the alert subsides, then OpsGenie will close it, and because Prometheus will send out a resolved signal, and then it will also be closed in ServiceNow with a message that it has been resolved. So that's how we're doing our incidents response. Also see that we have a different question, right, from Bart?
Yeah.
So Bart's asking, it's funny, it's my name. How are you running Kubernetes on Azure? Are you using AKS? Yeah, we are using AKS as the underlying system, but we are using Rancher to orchestrate it. And that's primarily a couple of reasons. Working with Rancher for us has been very nice. They've been very receptive to our questions. The software that they've built is very, very awesome. You could see the discovery operator that we built before. We've managed to build that through the Rancher API, so it gives us a lot of benefits. And we've done it also because it allows us to do both for on-premise and Azure have the exact same setup, and it makes us cloud native or cloud agnostic. So if at some point we also want to go to Google because you guys say, oh, it's tons better, then Rancher will give us that ability.
Okay, maybe I can pick up that software engineers. Yeah, like we have for the, how is it for software engineers to be on call? Well, we have like a virtual web team, and that are multiple teams, and from every team there's like 2 persons in there. And I think it's how do you say it? It's a good change. It's really DevOps. So I think it's great. How do you say that? It's great to have them in the rotation on that. So yeah, but I think you have to ask them about it. So
yeah,
and not us. So
I think so far it's pretty nice. We have a big group of people that want to do standby. People are often very helpful and very happy to do it. In particular, what we've done recently for our back office stuff. So then we're talking about the IT that really deals with the home delivery system. We have lots of different functional areas, and all of those teams are all doing on-call schedules, and it's been great actually. If I have to call them at night, which is often a very terrible thing to do, to someone, they're always very receptive towards either my calls or calls from automated systems. So yeah, I think it's going great. But as Sven said, you have to ask them directly. We have another question. How much freedom do you have in setting up the Azure subscription and AKS with it? And is that a requirement if you want to do this properly? We have a lot of freedom, actually. We have our own subscriptions that we are complete owners of, so we can do whatever we want, as many VMs as we want, as many as other stuff. The only limiting factor we have is networks, because network is managed on an AH.nl has level, except for bol.com, but like Go, Ethos, Albert Heijn, all of them, we're all going to the cloud, and we all have sort of this network set up. So there's a central network team that manages this, and then we get a couple of subnets, we get a couple of VNets assigned, and then we can split them up into subnets, and then use that to decide, okay, this cluster comes on these subnets, and then we can create network security group rules in order to create firewalls and everything between each other. But beyond that limiting factor, we basically have carte blanche as to what we can do on Azure and AKS.
Yeah. Okay. I think maybe a last one for the. You're still also running on premise. Yes, we're still running on premise. So we have like it's like 2 parts now. We have the stuff on premise, which is like our main infrastructure at the moment, but we're very busy with like the migration to Azure. So there will be parts picked up by a cloud migration team, and that will be set up in Azure itself. So it's harder to scale, but at the moment I think we have enough capacity left. But I think in this year, I think the goal is to have all of it in Azure this year.
Yeah.
So.
And the thing that we did with our solution was particularly also think about this 2-pronged approach, right? Because we want to solve the issues that we have on premise, and we want to solve whatever future issues we're going to have with Azure. So the solution that we have created now has really alleviated a lot of the issues that we had on premise, in particular with our monitoring setup, and that is also easily clonable now to Azure. So we're running the same setup in Azure. It doesn't have the same load, obviously, because we have less running in Azure. But so far, it's running good in on-premise, luckily. That's why we sleep well at night right now, because before it would be terrible. You would go to bed and you would think, oh God, I don't want to read in the news tomorrow morning that everything crashed and my monitoring system was down.
So yeah, I think that's it, right?
Yeah, I'm not sure what the procedure is now. Are we, because, well, I think some people are going to go to new talks, but if there are more questions,
exactly.
I mean, I can stay here for.
Do we have more questions? If you have more questions, we can take the last one.
Yeah, if you want to go, just go, and we'll keep answering questions.
Let's close it. Thank you very much for sharing very interesting, impressive talk, and also fun, and also your learning experience. Thanks for coming all over from Ahold and sharing it with us.